Hello, everybody. So I'm Thomas Voegtlin, the main developer of Electrum, the founder, actually. Do I have something to change the slides, actually? Yeah, remote. Thanks. So I'm going to give a different talk than last year. But this slide is in common. So Electrum was founded in 2011. The goal was to provide an alternative to either running a full node or having to trust a web wallet. So we tried to provide a user experience where users do not need to run a full node because this is difficult, and this keeps user from. Also, if you have to download the full blockchain, it can last several hours for people who do not use the Bitcoin client very often. So as you know, one of the properties of money is that it should be accessible. You should be able to use it instantly when you want, and you shouldn't have to wait. Electrum was one of the first clients that had this, I mean, it was the first client that introduced this seed concept where you can have 12 words and you can recover your money from this. Of course, you own the keys, that's the key point, and this is what I'm going to talk about in the context of Lightning. And do not trust, verify. So in the early days, it meant SPV. So the client uses a technique called SPV to verify all the transactions, which means that it uses a set of servers, it asks information to those servers about the blockchain, but it doesn't have to trust those servers. Okay, that's the big button, yeah. Not your channels, not your sats. This should have been the title of this, this talk, but I only found it yesterday. Yeah. So the trouble with Lightning wallets is that they are very often custodial or partially custodial, as in you have the on-chain part that is in your control, so you have the private key for the on-chain wallet, but the Lightning part is on a remote node. And for example, I don't know all the wallets, but in the case of Blue Wallet, which is one of the most popular, you can actually connect Blue Wallet to your own Lightning node, but that's probably not what 99% of people do. So they do trust the Lightning node of Blue Wallet. And so this is what, sorry, this is why I'm saying it's partially custodial. There is also more subtle differences, like for example, with the Phoenix wallet, it's non-custodial except sometimes. Like they open a channel to you, so you have to give them a pre-image for that. So it's going to be custodial for 30 minutes, which is okay, kind of. But with Electrum, we don't want to do that at all, because then our node would be a target for attacks. I mean, it's already a target for attacks, but a target that has a money reward. That's what we don't want to do. What else? Yeah. So your private keys in Lightning are with your channels. So the node that manages your channels has your private keys. Either it is implemented in your wallet or it is remote. But the private keys are associated to the channel. So wallets that do not implement the channels, they are either a front end to a Lightning node, or they are custodial. They are, they are either a custodial. Sorry, they are either a front end to a custodial service or to your own node. But if it's your own node, you should be able to maintain it, and this is difficult in the context of Lightning. So yeah, we need wallets that are that are lightweight and easy to use, but that are also trustless. So a question I get often is, why did we implement Lightning instead of integrating it? By implementing, I mean we really wrote in Python the Lightning protocol. And the reason is we wanted to avoid vassalization, as in we need a set of features in Electrum that other implementations do not necessarily have, because they do not agree on the priorities. For example, if I'm talking about Trampoline, Trampoline has been invented by Async. It is in Eclair, but it's not in the other implementations. And they kind of agree with it, with the concepts, but it's far down in their list of priorities. So it's not going to be in LND likely in the next year or two. And we don't have time for that. So that's also, so we want to implement the features we need. We don't have the same priorities as others, and we don't want a single point of failure like the async node. We want users to be able to open channels with arbitrary nodes. So here is a small comparison between Electrum and Phoenix, actually, because Phoenix is the closest to what we have. We borrowed from them the concept of the trampoline node, but in our case, you can do trampoline payments with multiple trampolines. So this is something we introduced, and users have the freedom to choose which trampoline they connect to. They have a very nice and user-friendly feature called pay to open, so that if someone needs to pay you and you don't have any channel, they open the channel for you. That's kind of fine. It's very, it's very nice, but it is custodial, so we don't want to do that. Also, we want channel backups to be recovered from seed, but without trusting the remote node, because we don't want to constrain to which node you connect. So in the context of Phoenix, you have to connect to their node because it is trusted both for the recovery from seed and for the pay to open thing. So since we want people to be able to connect to any node, we cannot use those features. We have to do it differently. Okay, I'm going to give a brief explanation of what is Trampoline and what are submarine swaps. So in the Lightning Network, routing is called source-based. So it means that when you want to send a payment, you have to choose a route for that payment, and for that you need to know about the graph. You need to have an up-to-date view of the network. So it has to be both complete and up-to-date, and this is an information that is quickly deprecated after. I mean, if you're not using your wallet every day, you need, in practice, you need to re-download the whole thing. So usually a mobile app is online only a few seconds before a payment, and then it goes offline. And that's also the case for the desktop version of Electrum. The usage pattern is that people don't leave the client open all the time. So Trampoline is a technique. I mean, yeah, okay. Trampoline is to Lightning what SPV is to the blockchain, because it really reduces how much data you have to download. You are just delegating the path finding to another node, and it's done in a way where, I mean, you have to trust the node to find a path that makes sense, but your interests are aligned with them because they are already part of the path. So they are not going to try to be twice part of the path or something crazy like that. I mean, they already have a fee for that. That results in slightly higher fees, actually, because you pay a large fee without knowing in advance how much the payment is going to be costing. And if the fee that you pay is not enough for the payment, then the Trampoline node is going to return an error and asking you to pay more. And at that point, you can actually, I mean, if we implement proper competition, your node could actually pick a different Trampoline node, saying, no, you're too expensive, I'm going to pick this one. Of course, for that, you need multiple trampolines, you need choice. And at the moment, we have only 3 trampoline nodes on the Bitcoin network. The first one, historically, is async. And Electrum has added 2 more. One is run by the Electrum company, and one is run by a volunteer. So yeah, if somebody wants to run another trampoline node, please get in touch. The more, the better. It's also better for privacy to have more trampoline nodes. Question? No, okay. The other feature that we have is submarine swaps. That's also part of our infrastructure. So the goal of this is to address liquidity issues. You might have a channel where all the funds are on your side, and so you cannot receive anymore. So that's the case. I mean, if you just open the channel, all the funds are on your side, and you're a merchant, you want to receive. How do? You can swap the off-chain funds, the Lightning funds, for on-chain funds. And it's called submarine swap. Yeah, it's done in a trustless way. so that you don't need to trust the service. It's not like you send them money and they send it to you back. Both payments are atomic. They can either they both take place or they do not. This works because of the particular type of contract that can be executed. So the on-chain contract shares the same secret as the Lightning payment. So if you do send the Lightning payment, the receiver is going to receive an HTLC for which they do not have the secret, because the secret is on-chain. Yeah, so you send an HTLC, and in order to redeem that HTLC, they need to send the funds on the blockchain, on a funding address that has this script, and then you redeem the funds on this address, and by redeeming it, you reveal the secret that they need in order to settle the HTLC. So this is why the payment is trustless and atomic. And if you happen not to do that, that's the other part of this contract. There is a delay, there is a timeout, after which you can get your money back. Well, I mean, whoever sent on the blockchain gets the money back. So in my example, it's the server, not the client. But it works in both directions. Okay, so we have two nodes run by Electrum. One is this swap server that I mentioned. So if you want to connect to it, I left the QR code here. This is the address of the node, and we have a Trampoline node. So the swap server uses LND and the Boltz framework, and it mostly acts as a sink. That means that liquidity tends to disappear in there because it's going to go on-chain. And the Trampoline is a source. So if you connect to it, you should expect liquidity to come to your side. There are other trampolines, like I said before, async, and the other one is called Hodlister. Async is a sink. That's a liquidity sink. It's not, I mean, the reason for that is that they have this pay to open feature where they open the channel for you. So basically users do not need to have any funds to start with async, but then they need to absorb those funds. So this is why you have this Trampoline that is a sink, while our Trampoline is a source of funds. Yeah, new Trampolines are welcome. And because also they improve privacy. If you can make payments and you have a choice between multiple trampolines, you can do multi-trampoline routes. So it's no longer like with the async node, where the async node knows both the sender and the receiver of the funds. Okay, how much time do I have left? It's okay. I mean, I have the other part is about spoiling the features of the next release of Electrum. 10 minutes. Okay, so this is a preview. I made just a bunch of screenshots. I've been lazy. I mean, I didn't want to risk the demo effect. So this is Electrum 4.3. It has not been released yet. What we try to do is to abstract payment from the payment layer, as in you don't need to worry whether things happen on-chain or on Lightning. We try to automate all this. So there is only a single type of invoice that contains both a Lightning invoice and a fallback on-chain address. There is a set of suggestions to address liquidity issues. So if you need to receive a payment but you cannot, if it's possible, to suggest rebalance, channel rebalance, and channel swaps. So here is how it works. I'm starting. Oh yeah, there is also, as you might have noticed, the balance is now shown as a single unified balance. On the bottom left is a pie chart, and if you click on it, you get the details about what is on-chain, what is confirmed, what is not confirmed, what is frozen, etc. Yeah, let's start with the channel tab. So this is a channel. I mean, this is a client with 4 channels. The number 2 here is not a channel. Do I have a pointer on this? Yeah. This is not a channel, it's a channel backup, that's why it's gray. So in this case, I'm going to show you the rebalance feature, which is new. This is this button here. So basically you have to select two channels that you want to rebalance. If you use Trampoline, the two channels must belong to two separate trampolines. And once you have done that, you can notice that the balance button is no longer gray. You can click on it. So you get this little dialog. It's asking you in which direction you want to swap between those two channels. And also you have a max button. So you can decide that you send as much as possible in the direction, and it's going to know for you how much you can send. So in this case, you notice how much those two channels can receive here. And now let's say I press max, the max button, and actually the amount here is matching the amount that you see here. Okay, and now I click OK, and after a few seconds you get this. So, sorry. So this channel now is at 0 in the can receive because the funds have been moved from this channel to this channel. Yeah, okay. And so this is still very technical. I mean, you have to understand what you're doing, but we simplified all this. I mean, I started to show you the complicated stuff, but it's actually integrated in the send and receive tabs. So let's say you want to receive, so this is the new receive tab. There is only a single create request button instead of two. We used to have one for on-chain, one for Lightning. And now if I press this, it creates a request like this. And you can choose whether you display the URI, the address, or the Lightning invoice. So that's the different QR codes have different sizes. You can also switch between QR code and text if you need to see the address or the Lightning invoice. Now let's say instead of receiving 2, I want to receive 3, and I press create request again. In that case, in that particular example, I don't have enough liquidity. So what's going to happen is that it's showing me this message. We don't have the capacity to receive that amount. You may have that capacity if you rebalance your channels. So there are two buttons, rebalance and swap. They do not always show up. They only show up if it's possible. And the client computes it for you. It computes which channel needs to be rebalanced and how much. Okay. So if you press on rebalance, if you press on submarine swap, you get this dialog, which you might already be familiar with if you use Electrum, except that now it's actually choosing the channel for the swap, and it's also choosing the amount that you need. But the swap actually is more expensive and is slower than rebalance because it goes on-chain. So the best is to choose the rebalance option if you have it. And in that case, you get this dialog, the rebalance dialog. Now it is pre-filled with the amount that you need. You just need to press OK. And after you press OK, you see the QR code. So the channels have been rebalanced. You are now able to receive that amount. Okay, now let's see the send tab. So again, when you want to send Bitcoin on Lightning, you might not have the capacity, or you might not have channels. So the client is going to show a pop-up if you cannot actually send. That shows multiple options. All those options are not there all the time because it really depends on the invoice and on how much you have, whether you can rebalance. But for the purpose of the demonstration, I show you the case where all options are available. So you can rebalance, you can open a new channel. Open a new channel requires that you have the funds, of course, on-chain. Swap and pay on-chain. Pay on-chain is if the invoice has a fallback address, which not every client supports today. Okay, so that's it for the new features, I guess. Yeah, I just wanted to make this announcement. I already made it last year. The electrum.org website is multisig. That means that all the builds are reproducible, and the website is not managed by us, it's managed by a script. So developers do not have access to the website. I don't have the power to change what's on the website. So basically, whenever we do a new release, all the new files have to be signed by 2 developers, and the signing keys for those builds are never in the same location. We never meet with the keys in the same place. Okay? And also, if I want to change the website, if I want to change the wording or whatever, this also needs to be co-signed by 2 people. So I no longer have the power to modify the website myself. Now, what do we do if there is a problem? Of course, we have access to it, but the key, the password or the SSH key to log into this machine is in a vault. And the vault is not at our office, it's in a bank, in a safety deposit box with the people with guns. Okay, thank you.